Hello everyone, welcome to the last section of Chapter 4. Yay! This is 4.8 and we will be talking about the attractive forces in compounds. In covalent polar molecules, they exert certain types of forces, and these are called dipole-dipole attractions. And remember, we talked about dipoles before, where you have dipoles where the charge is drawn to one side or the other because of the amount of negative charge there. Okay, and so polar molecules also can form strong dipole attractions called hydrogen bonds. And hydrogen bonds are going to occur between a hydrogen and a very electronegative atom on another molecule, such as oxygen, fluorine, or nitrogen. Okay? Hydrogen bonds are the strongest force between molecules, and they shape a lot of molecules, especially in the body, including DNA. Dispersion forces are weaker attractions between nonpolar molecules. Okay, dispersion forces you see between nonpolar molecules, and these are caused by temporary dipoles. Okay, that is temporary attractions that develop when these molecules bump into each other. Remember that molecules are moving all the time and they're bumping into each other, and they can only form a strong bond or a bond of any type if they get in the close enough in the right orientation. Okay, so dispersion forces are weak, but they make it possible for nonpolar molecules to form liquids and solids. So in an ionic bond, here you have in an ionic bond, it's very strong. In a covalent bond where you have two nonmetals, it's also very strong. Between molecules, because this is what? Between the atoms in a molecule. Between molecules, you have hydrogen bonds, which are the strongest. You have dipole interactions, where you have the positive and negative getting close to each other. And then you have dispersion forces, okay, where you are going to form these temporary dipoles between these compounds which are molecules, which are going to allow them to form solids and liquids instead of just gases. But the dispersion forces are the weakest. The next will be the dipoles, and then finally the hydrogens. Of these attractions between molecules, those hydrogen bonds are going to be the strongest. So the melting points are directly related to how strong these attractive forces are between molecules. The dispersion forces cause the melting point to be lower because of these weak forces. The stronger attractive forces, such as hydrogen bonds, increase the melting points. The highest melting points you see are in ionic compounds because of these really strong attractive forces between the ions within that same compound. And so just to give you an idea in a table, in these ionic bonds, the melting points is in magnesium fluoride is like 1,248 degrees C. To melt sodium chloride, it's 800 degrees. Water melting point is 0. Ammonium, it's minus 78. See how these are depressed as you go down. Okay, so these dispersion forces, the melting point is very, very low, isn't it? So identify the main type of attractive forces that are in these, and whether they're ionic, dipole, hydrogen bonds, or dispersion forces. Put this on hold. Look over here. Look at the chart. You got to decide what kind of interactions there are, and then you can decide what's going to happen to the melting point if you need to later. Okay, so when we come back to this, NCl3 was a dipole-dipole, water, hydrogen bonds. It can't have hydrogen bonds if it doesn't have what? A hydrogen, okay? So these two have hydrogens, so they can hydrogen bond. The bromine is going to have dispersion forces because it's nonpolar. The NCl3, if you look at it as a molecule, is what? Polar. And it has what? A dipole moment. So it is dipole-dipole forces. And then finally, potassium and chlorine, that's a metal and a non-metal. So that is what? Ionic. So it's going to have ionic bonds. And that's the end of chapter 4.8. That wasn't so bad, was it? The lab we did can give you some additional information, and I hope that you've enjoyed chapter 4. There is some extra practice on writing and naming ionic and covalent compounds in a worksheet that has been added to the Unit 2 under the chapter 4 materials, and so I encourage you to look at those and practice those as well.